Hello, pre-calculus. I have to tell you before I begin this is really strange. I'm sitting in my den all by myself talking, so it's just really strange. So as we move through this distance learning, just know I'm with you. We're going to get through this. At this point, we've got 4 weeks, and here's hope when we get back into school. All right, so here we go. 12-4. This is the wrap up of what we're going to do with matrices. So the objective is students will be able to solve systems of equations using matrix inverses and multiplication. So I'm just reading that objective. So here's kind of a big idea. I'm going to try and blow this up, okay? If you really start with matrix A times the unknown matrix X equals matrix B. What you could actually do is you could multiply both sides by A inverse. And then what's interesting is that A inverse times A is the identity matrix, and we saw that in the previous lesson. So then the identity times X is just X. So in order to solve, here's kind of the big idea. And I want you to write this down somewhere. So to solve a matrix equation, X, and the order matters, okay? Remember matrix multiplication, it matters. To solve a matrix equation, you're going to use X equals A inverse times B. So if we look at A, part A, I'm going to call this matrix A and this matrix B. So you're going to do A inverse times B. So use your graphing calculator. And let me grab mine and do it at the same time. So I'm grabbing a 2x2, and I know you can't see this. So you're going to put in matrix A, 5, 3, 3, 2. And when you get outside that matrix, you're going to hit caret -1, then arrow down times. Now, you want a 2x1, and you should see that in that button that's to the right of the 9. Hopefully you're getting the hang of this. So I'm going to put the 1 and the -3. And when you type enter, you should be getting 11, -18. All right, then letter B. Again, X is going to be A inverse times B. So let's do that as well. So pull up a 2x2. You'll put 3, -9, -2, 6. Hit caret -1, arrow down, times. Pull up your matrix that's a 2x1. And what I mean by 2x1 again is 2 rows, 1 column. And on this one, you're getting an error, right? And what that means, let me kind of go over this because we did this last time. You're getting an error, and it means that there's no solution this way, because if I look at the determinant of A, that's 18 minus 18, which is 0. So we cannot solve it using a matrix equation. So you do have to be careful. You're not able to actually get a solution from this matrix equation. And it's because if you remember in 12.3's notes, when you did an inverse, the definition was 1 over the determinant, and then you moved some of the pieces around. All right, so let's move down, and it says you can write a system of equations as a matrix equation, AX equals B, using a coefficient matrix So do you see this? This is where I'm reading. I'm trying out a new feature I found. Okay, so you can write a system of equations just using the coefficient matrix, a variable matrix, and a constant matrix. So if I have the system over here, 2x plus 3y equals 1, 5x minus 2y equals 13. All right, here's the coefficient matrix. You just list the coefficients, 2, 3, 5, negative 2. The variables are x, y, and the constant matrix is 1, 13. Now, I do want to pause here a moment, and if I did the multiplication, do you notice that is 2x plus 3y, and then I would get 5x minus 2y. And then remember, this is a beautiful connection. We can really connect this to earlier learning. Then 2x plus 3y equals 1, 5x minus 2y equals 13. So it all connects together. So in problem 2, I'm not asking you to solve, okay? So this is do not solve. All I want you to do here is write the matrix equation. So here's the matrix equation, because I am going to ask you to do this on homeworks. So you list the coefficients, so 4, 7, negative 5, 3. The unknown matrix or variable matrix is x, y, and then the constant matrix is 6, 1. Okay, pretty simple. Now let's try it with letter B. What do you do if there's 3 letters? This is where it's going to get interesting. I'm going to blow that up and let's change colors so you can see it a little better. All right, so watch this. I have A, B, C. So I have 3, 5, negative 12. There's no A in the second row, so I'm going to put a 0 here. I need a placeholder for the A. Then here, I do have an A, but guess what? I actually need to rewrite this in the right form. Okay, do you see that third equation here? Let me highlight it. This third equation is not in the right form. So I subtracted 3c from both sides. So now this is going to go 5, 0, negative 3. Okay, so be careful. Then my variable matrix is ABC. And then my solution matrix is 6, 8, 1. So all I wanted you to do here is just to be able to write it. So I am going to ask you to write matrix equations. Okay, I will ask you to do that. So let's look at problem 3. It says, what is the solution? And again, it says using matrices. So if you write just an answer down, you didn't show me that you used matrices. Okay, so let me show you the expectation here. So what you're going to do is you're going to write the matrix equation. And then the only other thing I want you to do that really indicates that you understand what you're doing is then I want you to write x equals a inverse times b. Then it's absolutely fine if you do the work on your graphing calculators. So make sure you're giving me the matrix equation and then give me x equals a inverse b. So then when I did this, so go ahead and do it, and if you have to pause, go ahead and pause. I'm getting 2, 1.5. What that really means is that x is 2 and y is 1.5. All right, if you need to, go ahead and pause this video, write the matrix equation, and then x equals a inverse b before you do your answer. Then when you have it, go ahead and unlock it or unpause or, restart the video and then check it with mine. I'm going to go ahead and keep working, but you pause it. So on part A, make sure you write the matrix equation, write x equals A inverse B, and then there's your answer. So what I have on this screen is the absolute minimum. Okay, this is the minimum. All right, so on B, you should be getting an error. There's no solution using matrices. So what's happening is this could actually be no solution or infinitely many solutions. So if you read the paragraph down below, and I'm going to start right here, it says the system negative 6x plus 3y equals 8, 4x minus 2y equals 10 has this coefficient matrix A, and the determinant is 0. There is no zero matrix. There is no inverse matrix, and the matrix has no unique solution. Recall that either means it's no solution, which means it's parallel lines if you graph the two lines, or infinitely many solutions, which is the two parallel lines. So technically, I don't want to say no solution, but it's indeterminate with matrices. We cannot figure it out. So we could do it algebraically, like you've learned before. So it doesn't mean you actually can't figure it out. It means you can't figure it out with matrices. All right, so we have one last one. So here we go. So I'm going to set up, no big deal. This just is a 3 by 3. And then my solution is going to be A inverse times B. And something I sort of want to point out while you might be working, maybe you can just be listening, is this is a 3 by 3 and a 3 by 1. So these match, and notice this is a 3 by 1 answer. So, I mean, this is why the dimensions work the way that they do. So then I got a solution matrix of -2, -3, 3, which if I want to write it as an ordered triple, it looks like that. All right, that finishes the notes.